y equals a sine b x minus c plus d. Now notice how this problem doesn't have a math operation here, so if I had to rewrite that, you can do something like that. I don't know if that helps. So in this case, my a is 3. And with an a value of 3, that means my amplitude is what?
3.
My amplitude is 3. My b value is equal to 2. What does the b value help us find? The period. So 2 pi over 2, that gives me a period of pi. Now, is there a c value? The c value would be 0, or in this case we could just say that the phase shift, shifting of the graph left to right, there is none. The d value is equal to 1, and this is our vertical shift, so that means going up 1, because it's a positive 1. Now, although you have parentheses, you do not have a c value, so you do not need to place this between 0 and 2 pi. Okay? Again, if you had something like x minus pi over 4 or x plus pi over 4, then you would have to move it around. Let's find our 5 x values. So now I'm going to draw my graph. Notice that the graph of sine is going to finish by pi, so I'm going to start here. I need 5 x-intercepts, 1, 2, 3, 4, 5. And my graph finishes by pi. So 0 plus pi is pi, and pi divided by 2 is pi over 2. Now, to get an equivalent fraction, I might want to call this one 2 pi over 2. And this one you can call 0 pi over 2. Now, this is 0, 1, and 2, and I need to find something in between these, so what I can do is I can double all of these. 0 pi over 4. This one becomes what? 2 pi over 4, and this one becomes 4 pi over 4. So what's in between it? 2 plus 4 is 6. 6 divided by 2 is 3 pi over 4. This one's going to be what? 1 pi over 4. So when it gets a little bit busy like this, then we can just circle what we have. This is essentially 0. This is pi over 4. You wouldn't use this form. You would use this one, pi over 2. 3 pi over 4, and pi is our answer. The ones in pink are our 5x values. But what do I do with each of those x values in pink? I take that value and I need to multiply it by 2. So now I'm doing 2 times x. So 2 times 0 is 0. 2 times pi over 4 is 2 pi over 4, and 2 pi over 4 reduces to pi over 2. 2 times pi over 2 just becomes pi. This becomes 6 pi over 4, which reduces to 3 pi over 2. And this one reduces to 2 pi. Class, what do we have here? These are the quadrantal angles. I call this kind of like golden row. If you do not get the quadrantal angles, you've done something wrong. Now, we need to find the sine of these values. So sine of 2x. So if you need to, you can always draw your quadrantal angles. Class, what's the order pair here? 1, 0. 0, 1, -1, 0, and 0, -1. Which one is cosine? The first one. And sine is the second one. So sine at 0 is 0. Sine at pi over 2 is 1. 0. -1. 0. The next thing I need to do with these values is I'm going to multiply it by 3. So 3 times 0 is 3 times 1. Okay. Now in some ways the problem might have been easier if it read it like this. Let me put it in red. 1 plus 3 sine 2x. We took the x values and multiplied by 2, found sine. We just multiplied by 3. Now we need to add 1. So in some ways, we're kind of going from right to left, or essentially the order of operations. So now I'm going to add 1. One plus 0 is 1 plus 3 is 4. 1 plus 0 is okay, let's go ahead and graph that now. So I have 1, 2, 3, 4. This one goes down to -2. Pick your favorite color. So I have 1, 4, 1, -2, and 1. So then I just have my graph that looks like this. Okay? Here's a couple of things I want you to note. The D value is kind of like a midline. And look at your midline here. Do you see that? That D value is this midline. Your amplitude is 3. Do you see it? The graph finishes by pi. The graph has not moved, so it's still stuck to the y-axis. Does that make sense? And it was pushed up. Normally we started at the origin when we shifted up 1 unit.